Right, hello everybody. My name is Chris Black, and I'm a software engineer and IoT enthusiast. And today we're going to talk about setting up a Raspberry Pi 4 to live stream to YouTube Live. So this is a live stream about live streaming. And given that a lot of people are working from home, and we have the kind of stay-at-home order in most states, trying to get people to avoid the spread of the COVID, thought that it would be very relevant to talk about how you can stream from home. So from what we've got here today, we've got a Raspberry Pi, we've got a power source, and we're going to be setting everything up from scratch. And this is kind of a redo of a previous event. My MacBook was not quite able to handle the stream, and so we experienced some choppiness and a couple of small gaps in the video feed. So we're going to go ahead and redo this using a desktop computer that is a bit more powerful and should be able to handle the stream at high quality without any issues. So with that, we're going to go ahead and get started. And as we go along, the other thing to keep in mind is you can use the chat window below to basically to ask questions as we go. There are going to be a couple of points throughout the feed that are going to be kind of ideal for taking short breaks to ask questions. Since we are going to be setting everything up from scratch, this whole process will take a while. We're targeting probably about an hour and 15 minutes to an hour and a half to kind of get everything set up from start to finish. So keep that in mind as well. And the video will be available after we're done so that you can kind of go back through and look over things. If you don't have all of the parts on hand right now, that's okay. You go ahead and follow along. And then when you do have the components, you can rewatch the video and get everything set up. Okay, so what have we got today? Switching over to a Raspberry Pi camera here that we have that is streaming through RTMP, and that is going through to my computer and out to you, so we can kind of take a look at the components that we have. So I've got the power source, the USB-C power supply. With a lot of the early Raspberry Pi 4s, it's very important to have the specific power source for the Raspberry Pi. They didn't work as well with some of the other power sources. That has since been resolved. Some of the newer versions. We've got our Raspberry Pi 4 with 4 gigabytes of RAM. Any of the versions of the Raspberry Pi 4 should work for what we're doing. The Pi 3B Plus may also work, but keep in mind that it may not work as well. Okay. I'm going to go ahead and open that up. And the other thing that we're going to have here is we've got a Raspberry Pi camera. And that is what we're going to use to have the video feed going directly to YouTube. Right. We've also got a heatsink as well, but I won't be installing that for the purpose of this video. However, it is important to keep in mind that the Raspberry Pi 4 does run pretty hot, and so you are going to want a heatsink in order to keep your Raspberry Pi cool, especially if you're going to be doing any extended live streaming from the device itself. Right, so we've got all of our components. We got everything set up. The first thing that we're going to need to do is get the Raspbian OS on our SD card. So we've got our micro SD card that we're going to put the operating system onto so that we can kind of get everything up and running on the Raspberry Pi, and so that we can install the software that we need on the device. Okay, so with that, the first thing that I'm going to do is take that memory card, and I'm going to take the memory card out of the SD card holder. I don't have an SD card slot on my desktop computer, so we're going to be using this handy little SD card adapter, and we're going to plug the SD card directly into the adapter. If you don't have an adapter like this, you will need some way of flashing the operating system onto a micro SD card. And so keep that in mind, that you'll need either an adapter like this or a computer that supports SD cards and the SD adapter. So now that the memory card is in here, I'm going to go ahead and put that into my computer. I'm going to switch over to my desktop view. Okay. There we go. I'm going to go ahead and cancel this. So I've got the SD card put into the computer. And the first thing that we're going to need to do then in order to install the Raspbian OS is go to raspberrypi.org/downloads/Raspbian. And this will allow you to download the operating system that we're going to need for the device. So the download that we're going to use is the Raspbian Buster Lite. And this does not have a graphical interface like the other versions of the operating system do, but it will be a little bit faster in terms of processing if we don't have to worry about the user interface. So what this will do is install a very lightweight version of the operating system that we can access from the command line and get everything installed and set up. If you do need to have the kind of the graphical interface or would prefer that, you can give that a try, but the performance might be impacted if you install one of the other versions because it's got an operating system to kind of the graphic layer to run on top of that. All right, so we're going to download the zip of Raspbian Buster Lite and have that download here. And now, just for the sake of time, I did download this in advance. And so while this is downloading, I'll kind of talk about the other tools that we'll need. But I do have it downloaded, so if it ends up taking a while, we can use the version that I've got. The other thing to keep in mind is that there is a blog post about the steps for this process as well. So as we're going through, most of the steps that we're going to be walking through are documented in the blog post. So keep that in mind. Excellent. So we've got this Raspbian Buster Lite downloading. We will need a way to get that onto the SD card. And there is a program called Etcher that is available on both PC and there should be a Mac version as well. All of these steps can be completed on PC or Mac. If you are looking for the Mac-specific instructions, feel free to reach out. I'll try to reference them when I can. I have gone through this process a number of times on a Mac and know that it does work there as well. Okay, so we're going to want to download this software if you don't have it already. I've already downloaded and installed Etcher for Windows. And so I'm going to show you what that software looks like. There we go. We have Etcher. So what we're going to do with Etcher is we're going to select an image and select our storage device and then click Flash. So I'm going to go ahead and take that image that we downloaded and we're going to take the Raspbian Buster Lite. We should be able to extract all. Extract. I'll let this finish. All right. So while this is extracting, so we're going to use the Etcher tool. We're going to select the drive that we want to use, and then we're going to erase that and flash the new content onto that. So with that, I'm going to open up a new window here just for a second. Okay. All right. So it does look like it's recognizing the memory card as two different boot drives. So we've got the boot and we've got the USB drive E. There we go. We got the Raspbian Buster Lite image file that we extracted. And all right, select an image, downloads. We're going to select the Raspbian Buster Lite. We're going to select the image file, and then we're going to select a mass storage device. Okay, oh, it looks like it is recognizing that D and E are the same device here. And so I have already flashed the Raspbian OS on this device, and that's likely why it's recognizing it as two different devices. But if you see just one or two, that's fine. If you already have Raspbian Lite installed on your Raspberry Pi, there's no need to redo this step. But we are kind of going from scratch here, so we're going to go ahead and flash it and go through all the steps from a fresh installation. So with this, we're going to hit flash. And what this is going to do is take that image, yes, and it's going to put it onto the mass storage device. This step does take just a couple of minutes, and so what I'm going to do is open up the Q&A. Go ahead and, if you have some questions, feel free to ask them right now or as we're going throughout the process. And if there are no questions, I can definitely kind of talk a little bit about some of the hardware that we're going to be using and kind of walk through some of those components as well. All right. So Etcher is taking the Raspbian operating system, putting it on the drive for us. Awesome. So the chat is working. Patrick is online. All right, no questions yet. So I'll just kind of talk through some of the next steps after we get this going. After you've basically flashed the operating system onto the SD card, there are a couple of things that you'll have to do to get your Raspberry Pi up online and connected to the internet. One of the ways that you can do this is to take your Raspberry Pi, plug in the memory card, and connect it to an HDMI monitor TV and connect a keyboard to the device and use that to kind of go through some of the setup steps. And so that's probably the easiest process to go through, just because you don't have to worry about kind of connecting to your Raspberry Pi from an external device. However, for the sake of this demo and video, that would be very hard to kind of present on camera. So what I'm going to do is go through a slightly more advanced setup, and I'm going to set up the Wi-Fi and enable SSH on the Raspberry Pi before I take the memory card and put it in there. So we can do a couple of things with the memory card that will enable those steps before we put it in the Raspberry Pi. So for those who have never installed, okay, so we've got a question here, and while that's validating, I'll go ahead and answer that. For those who have not ever installed the Raspberry Pi operating system, what are some good tips? Well, one thing is that the resources online are widely available. There are different installations and different versions of the operating system that are going to be easier to install. And so we've got an installation guide on raspberrypi.org. For what we're doing, live streaming from a Raspberry Pi is, maybe just a little bit more of an kind of a medium to advanced topic. And so we're kind of going the Raspberry Pi or the Raspbian Lite. But there are other tools. There's a Raspberry Pi Imager. There's the operating system that you can install that will let you kind of pick what you want in terms of what to install. If you are to select this version of the operating system here, you're able to kind of pick and choose one of many different types of operating systems you want to put on the Raspberry Pi. There are a lot of people that have done, like a RetroPie operating system. There's the OctoPi to manage 3D printers. So there's a lot of different kind of flavors or different types of operating systems that you can install on the Raspberry Pi. They're all kind of based off of the Raspbian image. And so if you're new to Raspberry Pi, have never used one before you go through some steps like this, you might want to just tinker around, grab a memory card, and install one of the graphical interfaces for Raspberry Pi and try that out first. And the great thing is that you can buy a couple of different micro SD cards and just plug in the one you want to use. So if you want to try the graphical interface Raspberry Pi, the normal path, then you can install that on one SD card, and then on another one you can install something else. One thing to keep in mind when purchasing an SD card, I'll have to double check if this limitation still exists, but the last time I checked, I think it was the 32 gigabyte card was the biggest card that you could use in terms of installing the operating system. So I'm going to hide that. Yeah, well, let's see here. So it says the flash is complete. However, it has one failed device. So physical drive 1, source and destination checksums do not match. All right, we're going to go ahead and kind of move forward, assuming that this did work. If for some reason it didn't work, I might try to reflash this using my Mac computer. I have not actually seen this error before, so I don't know whether or not this is going to be a full blocker on this. But I do know that I have flashed on Etcher from my Mac, and I can do that if for some reason this step did not work. So I'm going to kind of move forward with the assumption that that did work. And what I'm going to do is remove the that USB adapter from my computer here and plug it back in. And what that will do is it will now recognize it, and we do not want to format the disk, so I'm going to hit cancel. And what we're going to do is we're going to see that there's a boot, and this actually all looks like I would expect. And so I'm again going to just ignore this warning that's happening here, and we'll maybe do some research on that after the fact. So what we're going to do is, again, we're going to enable and set up the SSH on the device. All right. So to do that, I am going to open up a command prompt and clear this screen. Oh no. Clear is not recognized for an internal command. All right. There are ways to clear the command prompt in Windows. I am going to have to look that up in a little bit. I'm used to using my Mac has been my primary computer, and so I'm going to need to brush up on some of my command prompt alternatives there. But I do know that switching to the external drive, we can type the name of the drive. So we want to go to the boot drive here. So once you flash via Etcher, you should be able to remove that adapter, plug it back in, and now you should see a boot drive, D, or whatever drive it ends up appearing on your computer. And because it's on my computer, it's the D drive, I'm going to go to D:, and that shows us that we're on the D drive here. And then I'm going to type dir just to validate I'm in the right place. And you should see all of the files for the Raspberry Pi. And if you do not see these files, if you see something else, that means that it's on a different letter, and you'll want to just make sure you match that letter when you switch over to that. Okay. So now that we've got this on the switched over to the D drive, we're going to do a couple of different things. We're going to make two different files. The first file that we're going to make is a file called SSH. Okay, and looking at my notes for that, if we want to create an empty file within command prompt, we can do type NUL and then do an arrow, and the file that we want to create is we want to create SSH as a file. And just having this file on the device will tell the Raspberry Pi when it boots up that it should enable SSH. Okay. So now that we've done that, we've created a file called SSH. We should be able to type dir/a, And we should see that that file exists on the device. And what this does is it enables SSH for the device so that we can connect to it remotely without needing to plug it into a monitor or a keyboard, which is pretty cool. The next thing that we're going to want to do is create a file called wpa_supplicant.conf. And what this will do is allow us to enter our Wi-Fi credentials so that when the device boots up, it knows what Wi-Fi to connect to. Okay, so what I'm going to do is we're going to go ahead and do the same thing here. If you hit the up and down arrows on your keyboard, it lets you go through the previous commands. I'm going to hit the up arrow a few times, and I'm going to create a new file, and I'm going to call it wpa_supplicant.conf. It's very important that this is typed correctly because the Raspberry Pi is going to look for a specific file, and we're going to add our Wi-Fi credentials into that file. Okay, so now that we have that file, we should be able to see it. There it is. If we go to our boot and we look at the files, we should see that there is a file here with the name that we just supplied. So I'm going to go ahead and open this with Notepad, or you can use any other text editor, and we're going to edit this file. Okay. Notepad. So with this, in order to set up our Raspberry Pi on our network, we're going to go ahead and I'm going to copy and paste a couple of things in here, and then we'll talk about it. Okay. So these lines of code here up at the top are just things that you're going to need for the Raspberry Pi in order to identify. This is just a configuration file. The pieces of this that we'll want to adjust, I'm actually going to remove this and instead type key_mgmt equals WPA-PSK. It tells us what type of a network we're connecting to. And what we're going to do here is you're going to put the SSID of your Wi-Fi network and the Wi-Fi password for your network here. As an alternative, if you do have an Ethernet cable available, you can skip this step and just plug it directly into an Ethernet cable. That's another option. But if you don't have an Ethernet cable and you have Wi-Fi, you're going to want to type all of this and make sure not to put spaces after the equal signs here. Leave those like they are. And we're going to type our SSID here and replace this with our password. Now for just network security reasons, I'm not going to put my actual SSID and password on the video recording here. I'm going to move this to the other screen and type that in. And then I'm going to save the file and we're going to plug it into the Raspberry Pi and we'll be able to see if that worked. So I'm going to go off screen and I'm going to type in my SSID. And I'm going to type in my password as well. Okay, 5. And the Raspberry Pi 4 should support 5 gigahertz networks. If you have one, that would be preferable to connect to. Some of the earlier versions of Raspberry Pi, I'm not certain whether they, at which point they supported 5 gigahertz. And we keep that in mind that if you're using a Pi 4, you should be able to connect to a 5 gigahertz network. Okay, so I've done that. I'm going to save the file, and I'm going to close that file. That all looks good. It's important to just double check this step because if it doesn't work, it's just not going to show up and it's not going to be able to connect to Wi-Fi, so it's better to just double check that everything looks correct. So we created our we created the SSH file. It doesn't have to have anything in it. And then we created the WPA_supplicant.conf and added our Wi-Fi credentials. The next thing we're gonna have to do is just switch in our command prompt back to our main drive, which is generally your C drive. And what that will do is allow us to safely remove our boot drive from our computer. So we can right click on the boot drive and we can click on eject. And that will safely remove the hardware from the computer so that we can unplug it. Cool. So now that the drive is has been ejected, we can unplug it from the computer. Okay. And I'm going to just do one thing real quick. I'm going to switch over to my Raspberry Pi feed so that you can kind of see the next steps as I am completing them. Okay, so we've got our Raspberry Pi and the memory card right here. That should have our flashed operating system on it. It's a little bit tricky to get it out of this. There we go. And we're done with that. Okay, so we have not plugged it into power yet. Something to keep in mind that if you're going to be tinkering around with the Raspberry Pi, make sure that you disconnect it from power before you start changing things and adding things into the Raspberry Pi, just to avoid short-circuiting anything that you have on the device. Another thing that you can do is 3D print or purchase an enclosure, to help keep the circuitry protected. A lot of the enclosures will also include, ways to have fans set up. You can use an enclosure to kind of help protect the device once you start using it a little bit more for the intended purpose. So what I'm going to do is insert the memory card into the device. The location for the memory card is on the bottom of the device. And what I'm going to do here is just put the memory card right in there. And with the memory card in the device, it will stick out just a little bit, but that will allow you to kind of remove it with the case that you have set up. And with the memory card in the device, we can now before we connect it to power, I am also going to put the Pi camera, and I'm going to plug that in as well. So we got the little Pi camera here, and what I'm going to do is, in order to connect the Pi camera, we are going to want to just very carefully lift up on these. So the camera is going to go into this area here on the device, right by the microphone or the audio out line. And there are these little black tabs that you can lift up on, and this will allow you to kind of connect the camera. So I'm just very carefully going to lift up on these tabs, and these are probably one of the more delicate things on the device. I've broken these on a Pi Zero many times. So just be very careful when you lift up on those tabs. And then what we're going to do is insert the camera, keeping in mind that only one side has the contact pins. You want to make sure that you're putting this on the correct way. And we're going to use we're going to put the blue side of the tape, or the side without contact pins, is going to go towards the black bar. And we're just going to very carefully slide that in, that ribbon in right like that. Okay, and at this point, once it's connected, it should go most of the way down, and you should be able to see the just a little bit of the contact or the pins there as it's fully inserted into the device. And then now we want to kind of very carefully push down, providing kind of maybe some uniform pressure here on both of the pins on both sides of that, and requires a little bit more force to get down, but then once it's down, it kind of snaps into place there. There we go. It will give just a little bit of a snap. And now, once that's in there, it should be fairly secure, but you'll still want to be very careful with the ribbon. So now we have connected our Raspberry Pi camera. and our memory card. Okay, so I've already connected the power to the power supply, and I'm just going to plug that in here. I'm going to weave this around my computer just to help keep the cords in place. And we're going to plug the power into the device. Okay, so I'm going to plug it in, power here. Okay, so the device is booting up. And if everything worked correctly, we should now be able to see this on our network. Right. So in order to check to see if there's a Raspberry Pi on the network, this is something that's easier to do on a Mac computer than on a PC. So for those of you that might be on a Mac, the command for on a Mac computer to find Raspberry Pis on the network. Let me just do this and bring this over onto the other screen. Okay, there we go. On a Mac computer, if you want to find Raspberry Pis in the network, you're either going to type, you're first going to type this command, hit enter, and then try typing this command and hitting enter. The newer versions of the Raspberry Pi have a different, start with a different MAC address, and so you might need to try both of these. And when you do so, you should see a list of Raspberry Pis on the network. If you don't have a Mac computer, if you're on a Windows machine like me, the easiest thing to do at this point is going to be to plug that Raspberry Pi into an external monitor with a keyboard, and then check to see what the IP address is on the device from the device itself. Because the steps for Windows in order to get that to recognize the Raspberry Pi the first time requires a PowerShell script that I'm going to be running, but that might not be an option that everybody has available to them depending on the type of network that you're on. Okay, so if you're on a Raspberry Pi and you've connected it to your computer, you should be able to type one second here, just double checking this. All right. There we go. It's host name -I. So if you plug this into your into a TV or a source, a video source, and have a keyboard, and you should be able to type host name -I to see the IP address of the device. So this is a Raspberry Pi I have that's running, that's capturing the video feed, and that device is on, one of these is the Wi-Fi and one of these is the Ethernet, and so you can kind of see the IP address of the device, and we're going to need that in order to connect to it remotely. And so again, with the Raspberry Pi plugged into a TV and a keyboard, you can type host name space -I, and you'll see the IP address of the device. Because I don't have, with my setup right now and everything that I have running, I don't have access to do that at the moment. So I'm going to go ahead and run this PowerShell script that I was able to find as a resource online. And what this is going to do is force the computer to just kind of scan through and look for Raspberry Pis, the MAC address on all of the network potential options that I have available. So it's going to look through all IP addresses of the devices connected to my computer, and devices connected to my router. And if it finds one, it's going to put it in, it's going to cache it in the ARP table. And so I'm just going to go ahead and run this and see if we can find that Raspberry Pi that we just plugged in. And this will take just a moment here. As we run this, I did use this earlier to find my other Raspberry Pi on the network. Again, this is something that on a Mac computer, it's a lot easier. Instead of having to type all of this and run up a script, you can type this line and then this line, and you'll see that list and they just show up automatically. On a Windows computer, they just don't show up automatically, so we're not able to do that. So we'll give this just a minute, and if everything worked correctly, we should see our Raspberry Pi show up here when this is all done. Okay. Look at that. All right. So it looks like it found, during the deep scan, it found this device, which is the same as the one before. So you know what I'm going to go ahead and do? I'm going to go ahead and just run this on my Mac just to make sure that it's working the way I had expected it to. All right, DC-A632. I had expected to see a new IP address, so my Mac is picking up the new IP address. However, my PC was still unable to find that. So I'm going to go ahead and just try this one more time. If it doesn't work, I think we might just have to just determine that you, for this step, are going to have to plug it into a computer or use or plug it into a monitor or use a Mac computer to find the IP address, because it just looks like on a PC it's struggling to come up with that IP address for that device. So give this one more go, see if it can find it on the network. And if not, I'm just going to use the IP address that's showing up on my Mac computer and attempt to connect to it via SSH from there. But the good news is that it did appear on my network. A new Raspberry Pi did appear, so it looks like all of our steps up until this point have worked as expected. All right. Let's see. Did it find it? Nope, it did not find it. All right. Well, I'll have to look for some other resources. Apparently the PowerShell script was not quite enough for what we needed on that case. So what I'm going to do is go ahead and, again, I used my Mac to find this. You can plug it into an external monitor. What I'm going to do an SSH, and I'm going to type Pi, which is the default username for Raspberry Pi, at 192.168.1.125. So the IP address here is the one you found by typing that host name or using your Mac computer to find that. All right. The first time you connect to a device like this, it's going to say that it needs to accept the key fingerprint, and we're going to type yes because we know that this is a device we set up and we trust. You wouldn't want to do this if it was just some random device, but we set this one up. Okay, then the default password for your Raspberry Pi is going to be Raspberry, so RASPBERRY. And at that point, we should be in the device. So what we're doing, so everything we type at this point is going to be run on the Raspberry Pi. So we've kind of connected to it. And if you do have an external monitor and a keyboard that you can connect to the Raspberry Pi, you can do that as well. You only need to SSH into the device if you don't have a monitor or keyboard handy and want to communicate with the Raspberry Pi remotely from another computer. So again, for the sake of this tutorial and video, this is the easiest way for me to demonstrate this, but you are definitely able to just connect right up to that Raspberry Pi using an external monitor and keyboard. Okay, so now that we have the Raspberry Pi on the network, the next thing that we're going to do is install some things. And this step is what we have very thoroughly documented on the blog post. So I'm going to start typing some things here, and we're going to start just updating and installing all the software we need on the Raspberry Pi. So the first thing I'm going to do is type sudo apt update. We want to update everything that we have on the Pi before we start the installation. So I'll go ahead and do that. And while that's doing everything, I'm going to answer another question here. What are the minimum specifications needed to stream via Raspberry Pi? Can someone use an RPi 3? To stream at any reasonable quality level, I would recommend a Pi 3B Plus. It has 4 cores and is going to be much better at handling the processing needed for the stream. If you wanted to stream really low resolution, you could maybe get by with something less like a 2 or a 3, but you're really going to have to cut your quality and your resolution in order to make that work reliably. Anything less than that, and it's just going to be really hard for the Raspberry Pi to keep up quality-wise with the stream. All right. Okay, so that update is done. The next thing that I'm going to do is I'm going to do a full upgrade. So Raspberry Pi full upgrade. And this is going to make sure that we have all of the updates we need on the Raspberry Pi. So on the raspberrypi.org documentation, there's some documentation on updating. And before we get started, you should do the sudo apt update and then the sudo apt full-upgrade. Yes, I want to continue. All right. And that was sudo apt full-upgrade. These are the 2 commands that we've run so far. While that's going, I am going to answer another question. All right, why might somebody use a Raspberry Pi as opposed to just a regular computer? That's a great question. So that really depends on the type of streaming you want to do. If you want to do a video chat with your friends, you're going to want to use Skype or Hangouts or one of the many other tools available out there to do a face-to-face conversation. The live streaming that we're setting up right now is very much intended for kind of a one-directional purpose, broadcasting out to the world, which can be very valuable if you want to just stream, like you're doing a cooking tutorial or, want to be able to stream some IoT things that you're tinkering on, and you, with your web camera connected to your computer, built into a MacBook or a laptop, you might not be able to get the angle you want from your laptop. And the external web camera connected to your computer is going to require, again, you to be within a certain proximity of your computer and isn't always practical. So if you wanted to have multiple angles set up for your stream, or if you wanted to, live stream you playing a board game with your friends, it may make more sense to have a lower cost solution like a Raspberry Pi and something you can put, up in the corner of your room, or in basically adjust the positioning of the Raspberry Pi to where you want it. The other thing that you could do with this is this could be a fully remote or wireless setup. If you had like a 5 gigahertz network and you had a battery bank with the Raspberry Pi, you could be at a conference and you could be walking around streaming. And so it's a really great way to stream without some of the restrictions of having to be tethered to a computer with internet access, because the Raspberry Pi is just a kind of a tiny little computer and allows you to do that. So you can kind of think almost like you've got like a Nest camera that you have for home security. If you wanted to set something like this up for home security and connect it to your local network, that's how a number of people have used this type of a setup for that. Because if you have 5 different cameras you're monitoring for home security, you aren't going to have 5 laptops or big computers that you have set up. And so this is, again, low-cost solution to do video streaming either locally on a network or broadcasting out to YouTube Live. Cool. So that's all updated and set up. So the next thing that we're going to do is install Git, and that's Git, Git. So sudo apt install Git. Git is some software we're going to be using in order to download code from the internet and run it on our device. It's something that's used widely in the development community in terms of version control and keeping track of your the code that you're writing. For the purpose of this demo, we're just going to be using it to pull down code that we need to run on the device. All right. This is a pretty quick one, so we'll let that kind of run through. And then the next things that we're going to install are the audio libraries. So the YouTube live stream does require an audio source. So we're going to install apt-get install libasound2-dev. And it all looks correct. So we're installing some audio software that we're going to use to pick up the audio channel. Sudo apt-get install libmp3lame-dev. Okay, looks right. Yes, install. All right, and once this installs, we're going to install FFmpeg, which is the part of the process that takes the longest. Still isn't too bad. It's going to take a few minutes to get all of this up and running. There's a link from the blog post to the resource that we're going to be using. We're going to be installing FFmpeg on a Raspberry Pi. As we type these commands in, I'll copy and paste them into a text file so you can see them. It's important that you don't get too far ahead on this step, because when we configure FFmpeg, we will have to add some additional configuration options. So this step here is going to be different than what is listed on this blog post. Another thing that we're planning to do in the near future is bundle all of these commands up into a single install script to avoid having to type all of these commands individually, because there is a lot to type here, and there's a lot of pieces of software we need in order to get this all running. So the first thing that we're going to do is we're going to use this line here, the git clone, to get our coding software. All right. Looks like it's not letting me copy and paste, so I am going to be typing all of this by hand. All right. Maybe if I right click. Nope. Okay. So we're going to type all of that in. So git clone --depth 1 https code.videolan.org/videolan/x264.git. Okay, after we've cloned that, we can change our folder. So cd x264. We're now in that folder. And within that folder, we can configure the installation by typing /configure --host equals arm-unknown-linux dash GNUEABI enable dash static. I'm going to make sure that we there. Yep. Okay. And disable OpenCL. Okay. Perfect. So that's going to do the configuration. Now that we've configured the installation, we can type make-J4. The J4 is specific to the Pi 3B Plus and the Pi 4. It indicates that we're going to make this configure it with all 4 cores of the processor. All right, while that's going, I'm going to go ahead and answer another question here. Yeah. What happens if we connect a streaming video to 2.4 gigahertz Wi-Fi versus 5 gigahertz Wi-Fi? Yes, so I think one of the issues that we ran into when doing this with my MacBook was that it's an older MacBook and the processing power was a little bit lower. I do think that because of how many IoT devices I've got set up on my local network on the 2.4 gigahertz channel, and that the router was just so crowded on that network that it wasn't able to really properly handle that bandwidth. And so if you are going to be streaming 720p or 1080p, it's better to either be on an uncrowded network or, if possible, be on a 5 gigahertz network, just to increase reliability and make sure you have the bandwidth that you need. And so, if you can plug it into Ethernet or use 5 gigahertz, that is going to be much preferred over 2.4 gigahertz for streaming video. All right, and the next step we're going to do here is a sudo make install that software. That was quick. And then we're going to type cd ... to go back up one directory. And we're going to clone the next piece of software with git clone git //source.ffmpeg.org/ffmpeg depth of 1. So again, the code that we typed here was the git clone depth of 1. And next what we're going to do is cd into that directory. And we're going to do a .configure. Again, this is the one where we're going to add a couple of extra things to, so don't hit enter until afterwards, because this takes a while and you want to make sure you get all of the configuration we're going to need. And equals Linux. All right. -- enable -gpl -enable -lib x264 -enable -non-free. Okay, and there's some extra things that we need to add to that. So again, don't hit enter just yet. So this is a part of that blog post here. We are going to, in addition to what we have here, we're going to enable some additional properties here. So we're also going to need to enable libmp3 lame -- enable omx dash dash enable dash omx dash rpi. Okay, so I'm just going to double check that everything looks correct here. So we added the libmp3, lame, enable, perfect. That all looks good. So we're on to this step here. And just because I typed this all by hand, I'm going to just double check that, make sure everything looks good. Okay, I think that we're set to go here, and enter. All right, this is the one that takes a little while, so while this is running, the make part of this is what takes the longest. But we're going to see if this works as expected. We're going to give it just a minute here. There it goes. Perfect. And then now we want to do a make dash J4. This is the one that'll take a while, so we'll do a few more questions while this is going. All right. How much does Raspberry Pi normally cost? Yes. So the best place to buy Raspberry Pis would be at your local Micro Center, or at Amazon or Adafruit or SparkFun websites. And I prefer to go into Micro Center when I can, just to help support some of the IoT stuff that they've got. Micro Center, at least in Minneapolis, has a great selection of IoT devices from SparkFun and from Adafruit. They stock a lot of really great stuff and have tons of Raspberry Pis on hand. In terms of the specific pricing of the Raspberry Pi, I'm going to go to the Adafruit website and just look at the Raspberry Pi. And it looks like, in terms of just the device itself, if we have a Pi 3, it's about $35. The B Plus is also $35. The Pi 4 is $55 for the 4 gigabytes of RAM. And the Pi Zero is, it looks like, between $10 and $14, depending on whether you get it with the headers. Again, at a minimum, for this demo, you'll want the B Plus, or really what's recommended would be the Pi 4. And in terms of how much processing power this little device has, is actually a pretty inexpensive computer for a quad-core processor, and it has a lot of really great features. So great for tinkering and great for IoT. Again, Adafruit, Micro Center, SparkFun, Amazon. The other thing that you can do is, if you want to buy a kit, you can buy, so here's the Pi camera, version 2, 8 megapixels is $30. If you look, there will generally be some starter packs or kits like this that includes an enclosure, a power source, some different LEDs and things that you can get set up. And so, taking a look at some of the kits that are available help as well with making sure you get all the necessary components. I'm guessing that they have a kit for the Pi 4 somewhere, but would need to maybe do a little bit more research on that. Okay. And that question. So we already kind of answered this one. Where to purchase Raspberry Pi: Micro Center, SparkFun, Adafruit, anywhere that sells IoT devices. Okay, and the other thing to keep in mind is, once this installation for FFmpeg is done, I believe this is the last step, the last thing we need to install, so we'll be able to get the live stream up pretty quick after that's all done. All right. So what are some limitations of a Raspberry Pi versus a normal computer? The limitations are really just that the Raspberry Pi is intended to be a much more like a lightweight computer or device. It's not going to have, you're going to need an external monitor and a keyboard, and it's going to be running kind of a version of the Linux operating system. So it may not fully support, all of the potential accessories or things that you have out there that you want to connect to it. It honestly has been really good at interfacing with all the webcams and microphones that I've plugged into it. But in terms of, what are you going to use a Raspberry Pi for? It would be to, get started with maybe doing some coding for Python and Raspberry Pi to do some IoT stuff and tinkering. But the sheer size of the device is going to be kind of and the processing is going to be a limiting factor in terms of, depending on what you want to do with the device. Archive. Okay. Yes. Is it possible to add a microphone to a Raspberry Pi through the audio port? It's my understanding that the audio port on the Raspberry Pi is an audio out. So what we're going to be doing for the sake of this demo is we're going to try out this. I'm going to switch over to my, I'm going to get my feed back up again. Just a moment here. We're going to be using a USB device to connect to an audio source. Give me just a moment to start up my Raspberry Pi server here. What we're going to do is use this USB audio device and give that a go with a microphone connected to it. The other thing that you can do is plug in any USB capable audio device into any of the USB ports, and that will work. Most web cameras have audio built into them, so you can use that as an audio input, and they also make other accessories for audio input into a Raspberry Pi. All right, so this has got to be getting pretty darn close to finishing up here. I'm going to do one more display of the USB audio device, just for those of you that, just in case the question was blocking that. Okay, looks like we're still going with the installation here. All right. What are some of your favorite Raspberry Pi hacks that you have seen or maybe done yourself? Yeah, so we used a Raspberry Pi to create a thermal imaging camera for IoT Hack Day one year. That was a lot of fun to be able to basically connect a thermal camera to the Raspberry Pi and have that displayed onto an LCD screen, and that was a lot of fun. And seen Raspberry Pis used for all sorts of different projects, widely used for IoT Hack Day on many of the different projects and teams that were set up. Right. I also like using the Raspberry Pi to basically connect to my 3D printer. So I've got Octopi, and that allows me to send prints directly to the printer and monitor the status of those prints from the web browser instead of needing to go down and plug in a memory card every time I want to print something on my 3D printer. And so that's a pretty great way of using a Raspberry Pi, and I have a Pi Zero set up for that. Right, again, it's still doing the install. We're probably getting pretty darn close here, though, on on the FFmpeg. Again, this is the last thing that we'll need to install. So from here on out, it should be pretty quick. Okay. To command prompt. Right. Via SSH. Okay. So, again, we're getting pretty darn close here. I'm going to see if I can enable copy and paste on my command prompt because I am going to need to be able to paste something in here. Enable control shortcuts. Use Control Shift C and V to copy and paste. Looks like we can also cool. Let's see if that works once we get set up on this. All right. Let's do one more question here while this is finishing up. All right, answer. What is the difference between a console and a desktop? Boy, so for that, I would say a desktop to me is more of the graphical interface like we see with Windows, where you have different applications running. It's a little bit better user interface into, you know, the ultimately behind the scenes, computers are running a bunch of software, and you know the earlier computers just had a command prompt or terminal where you would just type commands in and then it would do things. You know, now we have computers that have the operating systems and desktops that we can interact with in a more user-friendly way. But the operating system and the desktop, the graphical interface does take up a lot of processing power and a lot of space on the device. And so with the Raspberry Pi, the reason we're doing this just via the command prompt instead of through the graphical interface is to cut down on the processing power because we won't need it for the stream, and to cut down on the file size of the installation. And that will give us better performance when we're streaming. Depending on what you want to do with your Raspberry Pi, you may or may not need the graphical interface. Like for example, the OctoPi for 3D printing doesn't have a graphical interface. It instead broadcasts through a web browser, so you can connect to the device through your web browser locally. So there are a lot of different ways you can connect to a Raspberry Pi depending on what you want to end up using it for. But if you're going to get into IoT and doing development for Raspberry Pi, you definitely want to get familiar with being able to connect to your device through a command prompt or a terminal window, just because a lot of the tutorials out there are going to require that you do something like this. Okay. Getting really close here, I think, on the FFmpeg installation. And then we're going to be able to, there we go, it's done. Whew, that's a long installation. All right. To make sure that that installation worked the way we wanted it to, we can type FFmpeg. Oh, we're going to do cd .mpeg bash ffmpeg not found. Oh boy. If for some reason I'm gonna go ahead and do a reboot because it should be able to find ffmpeg as a command on the device. So I'm going to do a sudo reboot and reboot this device. And then after reboot, we're going to reconnect to it and actually, I missed one step. We shouldn't need to redo the whole whole process here, but I did miss one step in terms of, a little bit ahead of myself here. We will need to go back to this URL, and the piece of this we missed was we did the make J4, we did not do the make install. All right, so we're going to cd into ffmpeg, and we are going to do the make install as the final step for getting ffmpeg installed. Oh, sudo make install, sorry. Okay, the installation should go much faster than the compilation, and then we'll be all up and running. Okay, so we're going to do one more of the Q&A here. Do you have any security recommendations for working with Raspberry Pis? Yes, the biggest thing is going to be to change that password from Raspberry to something other than Raspberry. Everybody's going to know that the default password for Raspberry Pi is Raspberry, and if someone's on your network, they could sniff for Raspberry Pis and SSH into it if you have that option enabled. And so once we're done with all of this, the other thing that we could do is we could disable SSH connections to the device. By default, that's turned off. And that would be for security reasons. So once you have all this set up, if you don't find you're going to need that again, you'll want to disable that. But for sure, changing the password to something more secure is going to be very important for the Raspberry Pi. The other thing that, long term, if you are going to be deploying this out into like a production environment and using these for, things that are going to be long running projects, you're going to need a way to update the software on the devices remotely, and you can use something like Docker to help manage images and push those updates remotely, because one of the biggest security concerns with IoT devices is just how to keep them up to date, right? If you don't have the latest software and aren't updating your operating system, you're leaving those security vulnerabilities open. And so if you're just tinkering, doing IoT stuff, and you have the Raspberry Pi in your house, you can always connect to it and update the software and update the libraries that you're using. But if you deploy this out into the field and are powering it with let's say a solar panel or something like that, how do you get to that device to update it, right? And what is your plan for that long term? So those are some things to keep in mind in terms of security considerations. Definitely change that password from Raspberry to something else right away. Okay, now if we do a cd ... and we type ffmpeg, there we go. That's what I wanted to see. So ffmpeg is installed. Whew. Okay, now what we're going to do is with ffmpeg installed, we're going to copy this. Cool, that works. All right, and we're going to take a look at this, and it's going to say cannot open device dev video 0. All right, so I know through experience that these 3 devices are not our Pi camera. Our Pi camera should be showing up on dev video 0, but it is not. So what we need to do is enable the Pi camera. So by default, this is turned off. And once we've connected the camera module, which we demonstrated earlier, there's a video tutorial for that if you need a reminder on that. But what we're going to do is sudo raspi-config. We're going to go to interfacing options and hit enter. We're going to hit the first option, camera, and hit enter. And would you like the camera to be enabled? We're going to hit select yes and hit enter. Interface is enabled. Okay. And we're going to hit finish after that. Would you like to reboot now? Yes. All right. After we reboot the device, we should see the Raspberry Pi camera appear as video 0. And give it just another minute to connect up. We're going to do an SSH to SSH into the device. And type our password. So this is a security risk. So that, again, like I said, change your password, typing in WD, and you'll be able to change your password on the device. So now I'm going to hit up a couple of times, and we're going to try to list the devices again. This time, we can see that there is a device on video 0, and this is the device that we're going to use for live streaming to YouTube Live. Cool. So the next thing that we're going to want to do is just take a look at the supported resolutions. Okay. For that device. And here we go. So this is where it's going to show us all of the different options and different supported, different supported options for the device. And we are going to be using, I believe it is H.264, so that is supported. Most of this other stuff at this point should be unneeded. Okay, and then if we type this command here, we'll be able to see our audio cards. So edit, paste. Right. This audio card here, I believe is not actually a viable audio source. And so what I'm going to do is plug in my audio source, the USB audio that I have, and we're going to see if that appears after I plug that in. So I've plugged in to the Raspberry Pi that USB audio device that I had. If you have a web camera, there it is, USB audio device. Perfect. If you have a web camera, you can type this and you'll see your device name appear here, and you'll be able to copy that from your web camera as well. So what you need to do in order to kind of do this final step here to connect to stream to YouTube Live, we're going to need this long piece of code here that we're going to run. So what I'm going to do is just expand this a little bit so we can see it all in one line, and I'll show you what we're going to change here. So the next thing we're going to do is copy. This should be listed in the blog post. I'm not going to retype this whole thing here. But the two things you want to change is what your audio card is, and in this case our audio card is named device. Kind of an interesting name for an audio card, but that is what it's named. So if you have something appear here that says microphone, or it might say 0xAB something something, you copy whatever appears here, and that's your audio source. Again, I do not believe that the ALSA is going to work for this, because I don't think that that's a valid audio source, but you might be able to try that out and see if that does work. And then the other thing is that we are connected to video 0. So if you have a Pi camera and another camera connected to your device, you might have video 0 and video 1 and video 2. So you just want to make sure you know which video device you want to be streaming. Okay, so that is correct. This is correct. And now we need the last piece of information, our stream ID from YouTube. So I am going to go to YouTube and show you what that looks like. Okay, give me just one moment. Okay. And go to there we go, YouTube. And when you open up YouTube and you log in, you'll have an option here to create a video or post, and then an option to go live. If you've never gone live with YouTube before, you might be required to validate your account and wait up to 24 hours before you're able to create a live stream. And right here it says webcam. I'm not going to do webcam. I'm going to do a new stream, and I'm going to give this a title of our Pi test live stream. And we're going to make this as unlisted and a description, our Pi test. So depending whether you want this to be broadcasted publicly or not, unlisted or private, those are the options there. And you can add a thumbnail if you'd like. And this is not specifically for kids, so we'll just say no there. And we're going to go ahead and create that stream. So once we create a stream, we're going to copy, so this is the URL that we're streaming to, and I'm going to copy this stream key to my clipboard. I'm not going to display it here just for security reasons. And that stream key is what we're going to need to paste into, give me just a moment here. Where is that window? There it is. That stream key is what you're going to replace this stream_ID with. So I'm going to take this off screen. I'm going to paste that in, and then I'm going to copy that whole command, and I'm going to paste it into this terminal window here. And again, because my stream key is in there, I'm going to take it off screen, and I'm going to paste that whole command paste. All right, for some reason it's not letting me paste that, so I'm going to try one more time. Copy. It's not letting me paste a multi-line command. So give me just one more moment here, and I'm going to see if I can open this up in a notepad or something else that will allow me to paste that into the application. So one more time here, I'm going to copy this. Not let me paste a multi-line stream into there. So what I'm going to do is just take out all of the line breaks, and we're going to give that a go without the line breaks. So this is a difference between Windows and Mac here, is that the Mac was letting me paste this in with the line breaks, but it does not appear that this is going to let me do that. So I'm just going to keep removing these line breaks. Okay, just one more moment here. And then I will paste that into the command prompt. All right, this is the final step. So if everything works correctly, we will be able to take this line of code and with the stream ID, And we're going to paste it into the, looks like it is too long to paste into the, okay, I'm going to try pasting part of it and then try pasting another part of it. All right. For some reason, it is not letting me paste this in here. All right, give me a... All right, so we are going to look at terminal, command prompt, options, enable paste. Okay, yes. I'm going to try to enable this via... Ah, perfect. Okay. Whew. So I was able to enable Control-Shift-V to paste, and that appears to be working the way I want it to. All right, so I'm going to go back and see if I can just copy that multi-line. So what I ended up doing here is I ended up going to Properties, and I enabled the use Control-Shift-V and C to copy and paste because Control-V was not working for me. And what I'm going to do is go back and grab that URL, and we are going to try this one more time. All right, device, and I'm going to copy in the stream ID. Okay, I'm going to paste this in offline here. Okay, so I pasted that in. Again, that was the command that I had set up, this one right here. So I copied this with the stream ID. I put my stream ID in there and I pasted it in, and now it is broadcasting, and it's broadcasting to YouTube. It says it's got an excellent connection. Aha, there we are. Okay, let's see if this works. I'm going to try to do ultra low latency to see if I could speed up the preview here. And we'll give it just one more second. There we go. Hello. There, I'm holding the camera here, so it's a little bit choppy. But what we have right here is we have the Raspberry Pi streaming the Pi camera. Just so you can kind of get a setup here, a picture of the setup. I'm going to go ahead and, yep, this is still streaming. That all looks correct. I'm going to try to restart the stream and see if we can get that working. So if you hit Control-C, it will stop the stream. Hit the up arrow, and we're going to try to rerun that. Okay. Stream is healthy. And I'm going to go live. There we go. Excellent connection. Okay. So what we have here, I'm going to go ahead and hit go live. And we're going to share out this URL. And I'm going to try to open this in another browser. One second. I'm going to copy that URL. And we're going to see if we can see us appear here on the live stream. There we are. Hello. Cool. So if you have the Raspberry Pi camera set up, Right now, I can point the Raspberry Pi camera at the other Pi camera here that's been recording the video feed, but I can switch over to, let's see if I can find a way to prop this up. Excellent. This is where having a 3D printed enclosure for this ends up being really nice. We can adjust some of the settings here depending on the quality you want and the speed you want for the stream. I will load that up here in just a second. So depending on the quality level you want for the video, the quality for the audio, the bitrate for the audio, the resolution that you're broadcasting, in this case, the frame, the keyframe, and this is the bitrate of the stream. And so at this point, everything that we have set up for this live stream is working as we wanted. If you want to look at the additional settings for FFmpeg to help optimize that, you can click on that. I'm going to flip back over to our camera here. Give me just one moment. All right. I'm going to go ahead and stop this for now. And I'm going to switch over to my other camera for a moment. All right, give me just a second. Get this started up. Okay. So, what have we got here? We've got a Raspberry Pi. We've got the Pi camera. This could be a web camera or a Pi camera. With the Pi camera, if you do find that it's not in focus, what you can do is you can use, it should come with one of these little focus dials, and with the Pi camera, while it's broadcasting the feed, depending on the focus you want, you can drop this in and it should catch on the little grooves there, and you can spin around the dial here to focus the camera and are able to focus that way. And I've got the audio source plugged in. Right now we don't have a microphone plugged into that, but you could plug a microphone into the audio source here or use an external web camera with an audio source as well. But everything that we have set up, we'll probably want to drop like a heat sink and a cooling fan on the processor just to kind of keep everything cool. Won't be installing that at the moment. But we took this from scratch, set up the wireless streaming Pi camera, and streamed it via YouTube Live. Again, use cases for this would be if you wanted to, stream, like if you had like a tutorial or cooking class, or wanted to stream some IoT stuff where you're soldering and you don't want to necessarily have to have your computer web camera kind of pointed right there. This would allow you to stream some 3D printing, or to stream some soldering, or anything you're kind of doing, which would be harder to get a webcam. And so if you're kind of building things or kind of want a more portable solution, this is a great way to have live streaming and be able to broadcast something out to the world in a very low cost, very portable solution. So with that, I'm going to jump over and check for additional questions and answers. And give me just a moment here. All right. So I know that this was, we're looking at about an hour and a half here from start to finish. But there's a lot to install. There's a lot going on, and this is a fairly lengthy process, but also a lot of fun just to kind of tinker around and see what's possible with technology and what we can build with a Raspberry Pi, and how we can make this work with YouTube Live. All right. So, what does a camera look like that you are using for your setup? Yes. So what I'm going to do is I'm going to switch over to my webcam, and we'll see if we can demonstrate what this whole setup looks like. Okay, so bear with me here. The whole setup, start to finish here, has, I've got a Raspberry Pi camera there, and behind that on the mount is under this box here, is a 3D printed enclosure, and this is my Raspberry Pi. I 3D printed an enclosure to allow for a little screen to appear on the top there. I don't have it in right now, but that's what the hole in the front is for. And then that's what's been streaming a lot of the content here. We've got the Raspberry Pi device that we've been using. We've got one monitor here that I've been using for managing the stream, and the other monitor here to get everything set up. And then the desktop computer behind that. So it's been I've got pretty detailed setup here to get all this working, but everything has been running much smoother here, and it looks like my stream has been much higher quality than the last time around. So now that I've hidden that question there, I'm just going to do this one more time here. We've got our Raspberry Pi device there, and the camera device here. I 3D printed both the enclosure and the little case for the camera there. And then we have our other Raspberry Pi that we were using for the live stream, and that camera does not have the enclosure. And then the kind of computer over here. All right, and put that back up there. All right, well, that's all I've got for you. So we've got the Raspberry Pi streaming via the YouTube Live, and you could also stream to Vimeo, you could stream to Twitch, you can stream to any RTMP server that's out there. You could even stream to your local network like I was doing for this video tutorial. I was streaming the Raspberry Pi feed so we could kind of see what we were building throughout the video tutorial, and streaming that on my local network so I could broadcast that out via the Vimeo channel here. And so, having a Raspberry Pi as an IoT solution for live streaming is going to be something that I think is, for many cases, going to be a cool implementation and a great low-cost way to add an extra camera to a live stream. The other thing that I've been tinkering around with is being able to stream, from different devices, so from phones, or if you've got like a VR headset or something like that. A lot of these devices have capabilities and ways to do streaming. And right now, with a lot of the social isolation, being able to share experiences and stream what the things you're working on definitely make the social interactions a little bit more powerful. And so it's good that we have that technology available to us for Hangouts and for Skype, and with web cameras and being able to do live streaming, which I think is something that is a reality that for the next few weeks or months that we're going to have to get familiar with and really take advantage of. So I'll close out by saying that thank you to anyone who's kind of hung in there and watched through the full hour and a half here, and hopefully if you didn't have the hardware on hand, you're definitely able to watch this video after the fact and go back through all the content and build this yourself. And also keep in mind that we have IoT Fuse coming up in a little bit, and it's going to be a great conference. I'm really looking forward to it. It's going fully digital to allow everyone to watch all of the content from their homes. And it's also going to be a great way to kind of watch the videos after the fact and just learn about a lot of really cool stuff going on in the IoT community right now. So super excited about IoT Fuse. Check that out. And again, thank you very much, and goodbye.